Dear students, hope you'd have done the analyzed type of simulation of a voltage divider by a circuit. Okay, now you'd have gained the confidence in working with this arcade PSPICE. Don't worry, it is very simple, right? Now let us do an experiment on frequency response. File, new, project, so frequency, the location it will be the same, analog or mixed AD, OK, create a blank project. A project window will be open. Place, part. So we need a DC voltage, right? Right click, end mode. And one more thing, we need an AC voltage. Left click, right click and end mode. Next, we need a transistor, right? Let us place the transistor. Right click, end mode. Next, we need resistor. Okay. We need 4 resistors. Right click, end mode. No, we need a few more resistor, right? 2 more resistor. One for the load and the another for the input. Right click, end mode. Similarly, we need capacitor. 3 capacitors. 2 coupling capacitor and 1 bypass capacitor. I'm just, you can place the components anywhere. I'm just know where we are going to make the connections exactly, and that's why I'm just placing there. Okay, no issues on that. So apart from that, we need ground connections. We can place the ground later. Clear? Right. Now let us rotate the positions. Rotate, and this is right click, rotate. Select the resistor. Right click, rotate, rotate, and this also. At sometimes you will be finding difficulty in choosing this capacitor. It will be chosen up to only one node. Don't worry. Just close this small window. Right click, rotate. So you can mirror it vertically. And this should be in the series position only. Right. Let me place the component somewhat closer to each other. Right. R1, R2, R3, R4, okay. So you have to choose that correctly. Okay, let me try it later. Right click, rotate. Okay, this has to be in the vertical position only. Therefore, right click, rotate. Okay. Place the wire connection. Yeah, one end of R1 is connected to the base of the transistor. The coupling capacitor is connected. The other end of coupling capacitor is connected to the source resistor. The other end of source resistor is connected to the AC supply. Clear? Right. The one end of R2 resistor is connected to the base. Connect the emitter resistor and also connect the bypass capacitor. This is for ground. Okay. Let me extend this for ground connection. Right click, end wire. Similarly, press place wire, connect this resistor to the collector, connect these two ends, right? You can connect it the coupling capacitor and the collector, sorry, load resistor. This is for the ground. Clear? Right click wire. Okay. So you can check the connectivity whether it is properly connected or not. Okay, both of the capacitor end has to be connected properly. The same way you can check any type of resistors and capacitors. Yeah, ground. Select this capsim. Give the name as 0. Press OK. Click here. Here we need a ground and here one ground. Connect this wire. Okay, now you can change the value. This is some around 20 volt. This we can have it as 40k. Depending upon the design, you can choose the values. So this we can have as 4k. Let it be 1k itself. And this be 2k. Load resistor can be 2.2k. And this capacitor is 20 microfarad. And this is 1 microfarad. And this is going to be 20 microfarad. Sorry, 10 microfarad. This RK. You can change the name of the resistance. This is RS, this is R1, R2, and this is going to be RC, and this is going to be RE, and this is emitter capacitor, CC2, this is CC1, okay, this is the load resistor, this is VCC, this is going to be VA. Clear? Yeah. Here we can have the input voltages 1 volt itself, right? So we have given the input AC voltages 1 volt. Let us see how our output is varying. Okay. Similarly, you can just zoom in. Okay, as well as zoom out. Right. Next, you have to go for PSPICE, new simulation profile, frequency, or give any other name, create. Right. Now you have to place your voltage knob at your collector. Okay, from where we are going to take the output. So this will be in the disabled condition until we press this play button. That is until we simulate the thing. Let us simulate what happens. Yeah, it is showing up the current value, but I don't want the current value. If you want the current value, you can make a note of it. So if you don't want means you just disable the current. Okay, let us see whether we are getting the output. Yeah, this under running. Why it is remaining empty means we hadn't created the profile, right? Just we have given the profile, but he hadn't given the content. So another window, simulation setting window will be open. This is the simulation settings. Okay, in this press AC sweep or noise. Already we know the frequency response is logarithmic. Give the start frequency as some 10 and this as some 100 gigahertz or something with a scale of 100. Apply, OK, and then press run. Yeah, this is the frequency response we have got. Okay, somewhat here we are getting certain deviations, right? Let us check whether we had made any mistake in our circuit component. Let me check over that. Yeah, what is the amplitude we are getting? Yeah, here it is not at all amplified. That's the thing. Yeah, this can be 10 microfarad. Again press this run. Yeah, now you can see the difference. Okay, by changing the value of the coupling capacitor, you can avoid that overshoot what we have got up there. Clear? Yeah, this is the way you can fetch your output. Okay, so here the frequency seems to be cut, right? You can edit your profile. Just click this PSPICE edit simulation profile. You can give the frequency as some 2 Hertz. Apply. Okay, now give run. Yeah, this is the response we have got. Is it clear? Yeah, so for your experiment sake, we have to take this diagram, screenshot of this particular diagram, and then we have to take the simulation profile. Okay, simulation profile. Next you have to show the output figure window, and finally you have to show me the netlist, PSPICE view netlist. Yeah, it will be opened in your session log, I think so. Let me minimize this. Yes, the time is going to finish. PSPICE. It will take certain time. So if you press this view netlist, your program will be generated over here, right? So any doubt? Or you can go to the view option, press output file. Go to the view option, press output file. So this is the file you will be generating. Apart this is referred as your netlist. So voltage source VCC is connected in between these two nodes of voltage 22. A voltage source of Vin is connected in between these two, whose DC voltage is 0 and AC is 1 millivolt. And all the things will be given up here. Okay, at the same time you can measure what is the corresponding node voltages and current. So all the parameters will be displayed over here. The transistor is having a current gain of 256 around, right? You can change the values also. Okay, so here you can get up to what is the total power dissipation in doing this particular experiment and what is the job time. It has taken only 0.06 millisecond to get the simulation result. Okay, once everything is done, to get the simulation output, it has taken only 0.06 millisecond. Okay, so if you are going to have some practice, at least if you could do 1 or 2 experiments, definitely you will be familiarized with the thing. It is very 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 easy. Okay, good luck, happy learning, and prepare well. Thank you.